Hello and welcome to stream number 90 in this series where I am programming an NES game live on stream from scratch. Let's get started. We're starting a little bit later than usual, so I'm going to try and keep this one relatively short. I'll start by just a couple of things. So Monday of next week I was thinking... Well, I wasn't thinking, and I'm going to be away, so I'm not going to be able to stream on Monday, so we'll pick up on Thursday of next week. And then the other thing I wanted to mention before we got started was one thing that was brought up in Twitter, and I tried to explain as best as I could, but Martin, who's on the stream sometimes, pretty often actually, asked a question about why I was updating the memory the way I was here with the tiles first and then the attributes. So I figured we'd talk about that a little bit in detail, and then we can get into fixing the problem that we were having with this move to 16 by 16 metatiles. So he'd asked why not just update, a tile at a time and update the attribute at the same time as we update the tile. So, for example, update this one tile, and then the attributes are, over here, right? They're not really part of this visibly, but they obviously affect the way that this is rendered. So update this, and then update that part of the attribute table, so that would take care of the first two tiles, and then maybe do the next two tiles, and then do this part of the attribute table, and then do this two, and then do the next attribute table, and so on and so forth. And the reason for that is that the way the PPU updates work, and we've talked about it a little bit, but I don't know that I've gone into a super amount of detail about it, is that you use the register at 2006 to tell the PPU where you want to write to in the PPU's memory, because the PPU has its own memory, right? The RAM that we're normally writing to is for the CPU. The PPU has its own memory that it uses for determining how to render the game, right? So we have this 2006 address that tells it where we want to write to in the memory in the PPU, and then we have address 2007, which is register, which is what we want to write. And so typically what we do is we update, we do a couple of things. So if we go back to our code here, we read from 2002 because that resets the counter for 2006, right? There's an internal counter that the PPU uses to determine if we are storing the high byte or the low byte. And in this case, what we do is we read 2002 to reset that counter. Then we load A with the high byte of the value, and we store that into 2006. And then we load A with the low byte and store that into 2006. And then we can update the memory that we just wanted to update. So in this case, we're talking about updating 2400 in PPU memory, right? And then at that point, when we write to 2007, what we're doing is updating memory at 2400 and beyond. And the behavior that we see is that for every time you update at 2007, you do a store into 2007, the PPU increments the address that you're writing to. So we start at 2400, we write to 2007, and then it increments to 2401. Then this next right here, the store, gets written to 2401 and increments to 2402. And then we store again, and we write at 2402, and it increments to 2403, and so on and so forth. So while we can do what was suggested over here and bounce back and forth between the tiles and the attributes, what we really want to do is we want to write as much linear memory as possible, because the system was designed to be optimal, operate optimally under that circumstance. Sorry, I was checking to see if I had closed the door of the basement so that my voice isn't echoing up to the rest of the house. So that's why we do, first we set the position of the beginning of this memory here, and then we do a full sweep across the entire tile set, the tile background. And then in theory we could just continue writing our attribute data, and we might want to end up doing that because the attribute data, this part here is 960 bytes, right, for each of the tiles that make up the background. And then the remaining 64 bytes, these are your attribute bytes. And that's what controls the color palettes used by the metatiles. And in theory, we could just write that afterwards if we pre-computed the attribute value first. And then we could just do one long run into the attribute memory. But we're not doing that right now. We're doing it into two parts. It's maybe we have to, change that later on. But I just wanted to explain that in some more detail, since I think I've explained it before, but I wanted to make sure that everybody was clear on that. So hopefully that was clear. And we'll see. He said he's going to watch the recording in the morning, so we'll see what he says. So going back to my code here. So where was that at? We were at the point where, so we're getting, if we jump back to here, here's the game after it loads the first screen. Here's what it looks like entiled. Obviously we had the problem with the attributes not being updated properly when we left off. Last time, what we had said was the problem was that it was not properly updating the attribute nibbles, because the issue is that we have to essentially update the same bytes twice in the attribute buffer. There's probably a better way to do that, maybe by traversing. So what we're doing right now is we're just traversing one row at a time and updating the attribute buffer that way. We could probably traverse both rows at the same time and then calculate one attribute buffer byte and then just store it one time. That might be better than what we're doing right now. Let's see how complicated that would be to do. Let's see. So this is where we're actually right, so we're just updating the attribute bytes by storing the whole attribute buffer into the PPU. So let's see what we're doing here. So this part we're taking, maybe that'll be better. Maybe that'll be better to do it the 4 tiles at a time, because then we can compose the one attribute byte. Right, because right now, while it logically makes sense that we're traversing the entire row one row at a time, because the attribute consists of essentially one of our full metatiles, maybe it makes sense to work in a cluster of 4 every time. And there's a little bit more work that has to be done to keep track of that, but then when we update attribute buffer, we've got 1 byte to update, and we don't have to keep retraversing that memory. Let's try it. I don't know that will actually work, but we'll give that a shot. So, and then what's the other nice thing about that? It gets rid of this whole nonsense of the different different modes that we're using to store the data. So you can literally do something like, let's think about this. So we can use attribute index to keep track of where we are. So let's say load y with attribute index. Well, it's already set that way. So let's start with this. So y, that gets stored into temp, and then let's increment y and load sprite mem, and then stop that, and then store that into temp2. Or you know what, we don't even have to do that. We could use, that would even be better. Be even a little bit, yeah. So okay, so we increment y, we store a, just gotta think about this again. So the top, this is the part that always confuses me. So the top left and top right are the lower, the least, or the least significant nibbles in the attribute buffer. I always have to pull up this page on NestDev because I always forget. So it's because the order is not, I mean, I guess it makes sense, but it's just, it hasn't really stuck in my brain yet. So it's kind of in the opposite order that I was thinking. So left, right, but from least to most significant bit pattern. So this stays the same, and then we do this, and then we want to shift twice to the left, and then we want to or temp to that and store that into temp. Well, good. I don't feel so bad then, Banshiku, if you don't remember it either. All right, so then that gives us our first half of what we need. And then we want to, let's see, so y should be incremented now by, how many, 16 metatiles across. So we've already incremented by 1, so we want to transfer y to A and add 15 to that to get to the next row, but we don't want to go exactly to, we don't want to go from, oh wait a minute. Wait a minute. Am I being dumb? I think I'm being really stupid right now. If our... Oh, no. Okay. No. I forgot. Okay, our I confused myself. So I was thinking, oh, well, this is 32 by 32. I was thinking that the attribute byte was 16 by 16, but it's not. These are actually the 16 by 16 inside. So we need to grab these two now, right? So we incremented from here to here, and now we need to go from here to here. So we don't want to add 16, we want to add 15. So we add that 15, and then we load a sprite mem y. I wish it would stop doing that. Alright, so we load a sprite mem y, and then we want to shift that by 4. I suppose I could just do, well, that's alright. I'd rather have it completely spelled out here than we could technically do, you know, repeat 4 like that, but for now, it doesn't really. It's not like it actually does anything other than it's just a shorthand. We'll do it for the ones coming up because I don't need to copy and paste them 6 and 8 times, but for 4, it's all right. I don't know what the cutoff is. I guess it's like if I just whatever feels right. So then all right, I've shifted those, so I want to OR that with temp, store that back into temp, and then we have our last one, which is bottom right, and that should be the highest. Yeah, okay, that actually isn't too bad. So we store that, and then we increment y, load sprite mem y. Oh, forget it. I'm not going to fight anymore. And then this is just repeat 6. ASL and repeat. Oh, and rep, and then OR a with temp, and then store a and back into. Then we want to store that into attribute buffer x. Right? That gives us what we're looking for. And then, oh, you know what I didn't do? I transferred the y to a, and I did the add, and then I never transferred that back into y. So that would have been a bug. All right. So then, now that that's done, we need to move y back to where it was supposed to be. So y was at 0. Now it's going to move up to 1. And it's just gonna, let's see, it's just gonna keep iterating. Well, no, it's gonna go by 2s in all cases. So, all right, so so the first thing we need to do though is we need to, if we're over here, we want to subtract 15. That might actually just be all we need to do. So transfer y to a. Set carry, subtract with carry 15, transfer a to y, and then what? So if we get to the point where we're at the bottom of the screen, what does that actually equal? So the bottom of the screen, bottom of the screen is going to be this part. So we're updating these quadrants here within each of these attribute bytes. Oh, Windows, you never fail. You never fail to interrupt my stream with some complete and utter nonsense. No. Let's pick tomorrow when I'm not using the computer. Let's say 2 a.m. Okay. That was not what I chose. Thanks. Oh, I gotta click the checkbox to confirm. Okay. I'm glad that was so important you had to interrupt what I was doing. Set my network to be metered. That might be a good trick. I don't know. I'd never heard about that one, but that, well, I may have to give that a shot. All right. So what was I trying to figure out? So I've got my it's 16. It's 16 across, and then what is it? 240 divided by 16. That's 15 down. So let's see. So y when y is down here, it's going to be 2 away from, well, it's going to be, okay, so it's going to be 15 times 16. That's our total number of metatiles. And then we're going to be not one row, but a row plus 2 more away. So minus 16 minus 2. So DE. So if I compare Y to DE, is that right? Did I think about that right? Because we're going to start with 0, we're going to go to 1, then we're going to go to 16, and then to 17, and then we're going to go back to 3 and 4, and then 18 and 19, and then we're just going to continue that pattern. And then once we get to 14 and 15, when we come back, there should be 16, which is here. I think that's going to work. So compare Y to DE and branch, if not equal, back to next attribute. We didn't do anything with X, so we've stored it here, but then we need to increment X, right? And let me think about this here. So it's 8 by 8. What did I say? It was 222. But how many bytes does that actually work out that I'm going to be doing here? Divided by 4, 55 bytes. That seems right to me. I mean, it should be... Well, it should be... There are 64 total. And then there are 8 per row, right? I think that's okay. Well, we'll see in a second. If not, we can always figure out where I goofed. So now all this complex stuff that we were doing can go away, because this is actually, in that sense, it's way more easy to do. You know, actually, that's even a better thing to check against. So compare X to 60. Well, it wouldn't. Is it 64? Yeah, it is 64. So okay. So, and then we don't need that. That's an extra one. All right. So we'll step through this because I'm sure there's some sort of issue with it. But 509 attribute buff. Oh, not parentheses, just that. Okay, so let's see what it looks like first. All right, well, it's actually closer than I expected it to be after such a major change. So, let's take a look at the code. So, next attribute. Let's make sure that this is all looking decent. So, all right. So sprite. So that's one. You know what? Also, let me go back. I made sure to commit my changes from last time before we got in here. I gotta get better at committing the changes after each stream so that I can refer back to them as I need to, because there have been a few times where I've made some significant changes that then I'm looking back at and I'm like, oh man, I wish I had saved those off, because it is a little bit more complicated than I thought it was. And yeah, Okay, yeah, so that's the right thing for the tile. If we go to PPU viewer, if we look at our palettes, this is palette 1. Oh, that's what we're not doing. I forgot about that. So I forgot the palettes are not offset. The palettes are offset except for palette 0 or palette selection 0. So if we or metatile 0. Sorry, because the palettes are evenly aligned 1-to-1 for backgrounds with the palettes. Palette 0 is tile 0 is palette 0 always, but then other metatiles need their palette value to be decremented. So we load A and then branch if not equal to here, meaning if it was 0, then we're going to skip this. Otherwise, we're going to clear set carry and subtract 1, and that's our. I should store that into 2. Let's do that. Oh, I've got to do that every time. That stinks. Okay. Something I didn't think about that. Okay, so we've got that. Do the same thing here. So if it's not 0, we just subtract 1 from the register. And then same thing here. And then we OR that, and we store that into attribute buffer X. Okay. That might be why it was the wrong colors. Where is missing here? I can even try and just see what happened. No, it's still wrong. Why is that? I'm surprised that that's still wrong because that should have done what I wanted. Let's load A 1 branch not equal. Oh. Dumb. That was silly. Okay. Okay, better. So we're seeing at least correct for the first one, but then it's off for the second one, and then the third one, and it continues to be. So it's close. I had the right idea. So let's see what's wrong. I assume that the problem is that when it gets to the end of the row, that's when we have the issue. We get to the end of the row. Yeah, so when the Y index hits the end here, the problem is that it's going to the next metatile, which we've already set. So it's then copying this one, and that makes sense based on what we're seeing here. So it's off by. So what do we need to do when we get to the point where Y is a multiple of 16? we want to increment y by a whole row, right? So after we're done with this, increment x, y, increment y, subtract c, increment this. Okay, so then before we do anything here, we want to say, okay, well, we can keep this because we want to test against a now. So if we test against 15, branch, if we get 0, then we want, so branch if not equal, meaning we didn't get a multiple and skip this part. But if we did get a multiple, then it will be equal or 0, which means that we then want to clear carry and add a whole 16 to it, and then transfer a to y again. Alright, let's see if that fixes it. That should be right, I think, now. Of course, this only fixes just the loading of the level. Whoa! Transfer y to a, set the carry, subtract, transfer a to y. And a with 15. Branch if not equal. To there. Otherwise, clear carry and add 16. So, what did I mess up? We're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We get to 16. We don't want to be over here. We want to be over here. So we say, okay, this would add 16. That sounds like what I did. Obviously not. So let's see what went wrong. All right, so y is 16. Oh, right. If we do the AND against it, a becomes 0. So we've got to transfer y back to a before we do the add, because otherwise we're adding 0 to it, which is why we get that repeating pattern instead of... So what we were seeing was it was repeating because it just kept doing the same... We kept getting the same attribute values every time instead of... That's why it did that pattern back and forth, right? So that should fix that now. Maybe that's right now? Let's see. Yes, okay. Cool. So now, obviously, the rest of the map loading code is wrong. So let's dig into that. Here, let's... stage selected. Initial level load is now fixed for 16 by 16. Great. All right, so now let's see. So we're now doing our camera modification. This is the check level object stuff, but I don't want to deal with that yet. I want to deal with the all right, we have all this stuff now. So now that our metatiles are 16 by 16, guess, do we still have the same problem as before with the split update mode, because our metatiles only span... Let me think about this. Or is it... Well, it's different now. Because before we were using 32 by 32 so that we could write 1 byte at a time, but then we were dealing with the fact that sometimes we were writing half of one byte and half of another and alternating. I guess now we're always writing half a byte as we load the row. Great. Surprised that it is spawning those enemies, but that might be a side effect of the way it's loading the data. So let's ignore that for right now. In fact, what I want to do right now, I think, is I want to remove... Where is the call? I thought there was a call to add the object to the level. Spawn at the top of the screen. This is the enemy type. This is the position. Increment load A. Y position. Check next byte. Done with objects. Check next byte. Object confirmed. Oh yeah, here it is. So let's just forget about adding the enemies right now and focus on figuring out how to make the... Whoa, that's weird. Why did it still... Did I not... No, it's still adding those. Okay, well... Alright, let's focus on how to get the metatiles loaded first. Alright, so previously we were doing a counter of 8 so that at every row we would load the next metatile, or the next piece of the metatile. So let's see. So every time we hit a row count, scroll counter of 8, we would increment the metatile sub-row and skip the row process. So now, let's see, load a 0 and restart that counter. Load a metatile Y, set the counter and subtract 4. Why 4? Oh, because, right, because we're going to the next metatile row, so we're subtracting the number of tiles in a row. So this becomes 2. So let's subtract number of tiles in metatile row, in this case 2, because it's 2 by 2, 16 pixel by 16p by 16p. Okay. So then we're going to store that back into mtile y. Let's see, compared to 8, so that we can update the attribute buffer for the remainder of the metatile, since we're doing this right. So before we were doing this at 8 because we would start at 16, or well, 12, and then we'd subtract 2 rows from the metatile rows, and then we would hit the middle, and then that would be the next row that we want to load. In this case, it's just 2. I like how confident I was here. Compared to 2 for midway point in metatile. So I'm going to update the attribute buffer the remainder of the metatile, since we're doing. Now let me think about this with the Alright, so branch if not equal to check for new metatile row. Otherwise, tile attribute fix it. Okay, so these are split update. I don't care about the attribute stuff right now. So I'm gonna leave that alone. Because this is all updating attribute buffer stuff. Which shouldn't affect the way that we load the actual tiles. So check for new metatile row. So let's see. FC, I believe, is because we would be at 0 and subtract 4. Yeah, so now we're going to be at 0 and subtract 2, so that would be FE. Check if we've subtracted 2 from 0 to roll over into negatives. Branch if equal to increment next increment metatile row. Okay, so we're going to another metatile row if we did this. Otherwise, we're just taking the current metatile row. So all right, so increment metatile row. So we load 12 and then we store it. So that was, so that's interesting. Because we actually here just need to load 2, which means that every time we come through here, well, it's going to alternate between 0 and 2, I guess, that check. Well, no, actually, this will never be true. Because we'll always... compare to the midway point in the metatile so we can update the attribute. We're always updating. All right, so that's related to the attributes. I don't care about that right now. So load 2, stored in mtile y increment metatile flag, set bit 2 to 1 so that we know we updated the attributes or the attribute mode value so that the bit 2 is okay. So load the row memory, the current location of where the row is. Oh, that has to get fixed. And then we'll fix that in a second. Alright, so set the carry and subtract 8, which is... let's see. And then stored in row mem. Branch carry set load new row. In some ways this may be simpler, but in other ways, because we've already got this 32 by 32 stuff written, it's almost, that makes it more complicated to fix what we've done. So here, after we're done loading everything, the problem is, let's see, so sprite mem goes into row mem. That's all okay. Actually, you know what? That's fine because sprite mem is the beginning of the okay. All right, so we don't actually have to change anything there. So load the row mem. And then subtract 8. Why are we subtracting 8? Because what? It's 8 metatiles across. So here we actually want to subtract instead 16. And then we store it because there are 16 metatiles. So let's notate that here. Subtract number of metatiles in a row. So the good thing about this is that we're going back through the code and doing a better job of describing why it works that way. Yeah, refactoring blues is exactly right, Bonshaku. It is, but you know, we get the opportunity to make sure that this makes sense and add comments that are more helpful than what we had before, because now we're kind of looking at it with fresh eyes and understanding it better and understanding how to explain it better than when we were kind of in the midst of figuring it out. So, all right, so we store that. Branch of carry set. So if we... Branch of carry set. So if it didn't go past... If it didn't go below 0, then otherwise row min plus 1. Okay, yeah, that's fine. So load new row. This is just handling the 16-bit math stuff. We could even, just so that it makes it feel, oh, but you know what, we need that label. Okay, never mind. We can do, can't get rid of that main label, but we can do this just to make it feel like it's less important than it is going to the label. I know that's kind of unnecessary, but okay, load metatile flag, all this stuff. All right, so now load the metatile value from the map data and then multiply by 16 to offset for the number of tiles per metatile. Okay, so instead of that, we only need to do it by 4 because the metatiles are obviously smaller. So let's change that to 4 to offset by the number of metatiles. And then let's see. One, two. So then that's it for this. We only need to do 2 because there are only 2 per. And then we compare against 16. So just make sure I'm doing that right. Yep. So store that into tile counter, compare against 16, and then branch of equal no more metatiles. Jump to next metatile. Load a metatile flag, compare 3. If this is 0, the flag wasn't set. We can skip modifying the attributes. Okay. All that stuff should be safe to just leave alone. I mean, the attributes are going to be wrong, but we'll figure that out later. So skip attributes. So load a screen mem plus 1, and then set the carry and subtract. So here, this we're subtracting 32. We're subtracting 2 rows. So we can, instead of doing that, we want to subtract that. Store a screen mem 1. Compare E0 branch of equal to. So let's see. So decrement screen mem. Oh, that's if we went past. Is that why? We were at C0 starting out, and then we were subtracting. Right. Okay. So E0 is if we went 0 minus that. So we need to check against C0 here. Now, is that going to be a problem? No. Okay, that works. The math works okay there. So then decrement screen mem, load a screen mem, compare to 1F. That's if we went too far past the bottom. Okay, I think that's all okay. Let's see what new monstrosity we've wrought here. with these changes. Okay. Oh wow. Okay. It's close. It's pretty darn close. So we're not exactly right. We're getting, I mean, the attribute stuff is totally wrong. I almost want to just it seemed almost right. Like we were getting, so that looked okay, but it wasn't updating this. This was okay. Here, if we go back to this for a second, let's look. So we get to this, and then we have this pattern. So it looks like it's not correctly updating every other row. And that makes sense that we might have that problem based on the way that it was updating before. So let's see if we can figure out where that's coming from. That was actually not too bad. So subtract number of metatiles in a row. Let's see here. So when we hit 8, load. Oh, you know what the other thing? Okay, hold on. There is one thing I just realized we're not doing. So if I remember right, there's a starting counter that we configure at the end of load level. So that's 23C0. Where is that? Set attribute index to indicate where we're... Okay, so that... I think that's okay. Mtile Y... No, that's alright. That was what I was looking for, the Mtile Y, but I guess that's okay. Because it would be 0 still. So we count 8, and then we're ready to do the next update. So let's see. So we store that into scroll counter, and then we load mtile y, which will be 0, and then we subtract 2, and then we store it, and then we compare it against 2, which it won't be equal to, so we go to check for new metatile row, which is here, and then we compare it against FE, which is correct, and if it's equal, we go to increment metatile row. So that's right. Then we're going to load 2 and store that into mtile y, and then we're going to increment this, and we're going to load the row memory location, and we're going to set the carry and subtract 16 from it, which is the number of metatiles. We're going to store that back into row memory, and if we carried, then we need to. Okay, so I wonder if row mem isn't correct. I mean, it should be. It should be okay. But I don't. Let's see. Store. That's row mem plus 1. And then do we touch that anywhere else? Yeah, so sprite mem then overwrites that value. And what was sprite mem modified with? Sprite mem was the beginning of the tile data of the level. Right, so that's where we loaded the... So we know that that's at least correct for the beginning work that we've done to load. Does it get modified at the end? Maybe it's not getting modified the way it should. If we go back to this, I actually want to look at our this change. I don't think we were doing anything special with ROMEM, or sprite mem, I should say, in any iteration of this. Where? Sorry to kind of drag us through the repo for this one. I just want to make sure that I'm not missing something that I cut out when we were modifying the code. It doesn't look like it though. Okay, so that points to the beginning of the level. So if we go back here for a second, we say because there's a spot where we actually modify ROMEM to, okay, so load A with 2, insert the Untitled Y, increment Mettaton flag, load A ROMEM, set the carry, subtract. So that's the first thing we're going to do coming through here is we're going to subtract the current row memory position from, we're going to subtract 16 from that. So we're going to subtract into a whole new row of metatiles. And then we're going to store that back into ROMEM. And then, let's see, load new row, Mettaton flag. Okay, so that, yeah, so if Mettaton flag was, load a Mettaton flag and OR it with 2, and then store A into that, and then load Y was that, and put that into tile counter. And now load the mettatile value from the map data, and then multiply by 4 to the offset for the number of the tiles per mettatile. So we load the actual mettatile index, and then we transfer A to X, and we decode or do our lookup of the mettatile into the global mettatile value as it is in the char ROM, and then we multiply by 4 to pass the other metatiles. We clear our carry and we add mtile Y. Why do we do that? Clear carry mtile Y, which will have 2 in it. So that gives us load A, ASL, ASL, add that, put that into X. So that's beginning of the row. Oh, because, yeah, so that controls the offset into, yeah, okay, no, that's fine. Although maybe that's a little bit strange, but okay, so we transfer Y to A, and then we push A, and then we load Y with the tile counter, and then we load the metatile value and store that into new tiles Y, which is our which is our row update. Oh, you know what? We're probably... Where do we use new tiles? So that's... So this shouldn't be 32. Oh no, it should be 32 because we still would have loaded 32. Okay. Sorry. We still should be loading 32 tiles in. And we do that in the NMI. Alright, so we're storing new tiles Y, and then we increment Y, and we increment X, and then we get our metatiles, and then we do that again and again, and then we store tile counter, and we pull A and transfer it back to Y, then we increment Y, and we say, okay, did we do this 16 times? Except, you know what? That should be... I wonder if that should be 32. Not 32 like that. Like that. Because that's the number of... Let's see. Pull A. What was... This is the... Before we pushed it, what did it have in there? It had the location of the metatile. All right, no, so that should be 16 because that's the location. Yeah, so here, let's put a note there. Push offset. Push metatile index into row mem onto stack. Alright, so if we've done this, get index off of row mem back. So if we've done this 16 times and we've traversed the metatile properly, so we do that. And then no more metatiles, and no more metatile here. I'm just gonna, let's do this. Jump, skip, attributes. I'm gonna skip all the attribute processing because I know it's wrong and there's no point in having it mess with the other stuff we're doing right now. So let's see what we're doing. So, seems like we're still not 100%. So, bear in mind the colors are wrong because the attributes are getting updated. It looks like we're only updating every other row of tiles, but that's still better. And that includes these, right? Where we're not updating this. So this has got the pattern from before instead of the water, which is what it's supposed to have. This should be fully solid. All right. So what are we? Is it because of the way? I bet it's not handling when the row is complete properly. So let's see. So this is the screen mem. And we're subtracting. This is too many, isn't it? Because let's see, every time we do an update, why would it have been doing 32 before? Right, that's what it was. I think that's what it was doing before. Let's look. I'm tired, and I'm gonna lean on these commits as a crutch for my brain not working 100% here. So it was originally subtracting 32. It was subtracting, let's see, skip attributes. So it was subtracting 32. Why? Because we did, probably because we did the 2, right, because we were only updating half the metatile. So we were updating half the metatile, and then we had to jump back and do the other half, and so that's, yeah, so instead of jumping back that many, we want to jump back, right, so instead of, now we have 16. Oh, it's actually the same, is that right? We're same number? I guess it's the same number, because it's still the same number of overall. But that makes no sense, because if it's 8, 2 rows of 8, that gives us 16, so then we jump back 32 to go back another 2 rows of 8. Now it's 2 rows of 16, so that gives us 32. So now we need to go back 64. Right, which is 40, which is what I had. Except we're not doing 2 rows, we're doing 1 row. Or we should only be doing 1 row. Which would explain the skipping we were doing before. Yeah. So now you can see we have a bug here, but you can see that the metatiles that are loaded are actually correct. We're still getting the occasional issue where it's not loading the right data, and it's probably some weird counting bug or something like that, but let's follow the rest of the map and see. And again, ignore the coloration and the attributes because we know the attributes aren't working. So we go back, we have another bar. Okay, so it's actually, it's pretty close. It's pretty close. Like this is actually mostly right. It's just, I'm sure some of these edge cases that are wrong. So, well, that's going to be wrong too, because now instead of it, so 0 minus 2, 0, it's E0, so this should be E0. Let's see if that fixed the errant metatile that wasn't updated properly. Yep, it looks like it did. So now the metatiles are getting updated correctly here. We still have issues with the attributes. I'm going to fix these just so that we can see the tiles properly without the issue of the colors getting in the way. So we are at 23C0 for our memory, so that means that let's I've got calculators open here. 23C0 plus 960, that puts us at 2D20 for our buffer for the attributes, right? 2D20, or did it? Oh, I added the decimal value to the hex value. That doesn't work. 2780. That makes more sense with what we were seeing over here in the memory viewer. It's interesting. Why does it look like the tiles are there? Is that the mirroring? Oh, maybe. Are we using 23C0 or are we using 2000 as our memory? Maybe we're using 2000 and I misremembered. It looks like that's what we're using. So if we're using 2000 hex plus 960, that gives us 22B2. 22B2. Looks like these are the attribute values. Let's yep. You can see as I go through and just brute force the update, it fixes the attributes. Okay, so let's keep running the game now. Oh, why did you do that? Something. Oh, you know what it is? We have our attribute buffer in memory, and I'm re-updating the attributes every cycle. Attribute buffer, what's it, 0? Really? Oh yeah, it looks like it. Okay. What is this? Scroll Y. So that's attribute buffer up until, I think that's more scrolling. 3, 4, 5, 6, 7, 8. I want to say that probably will fix it. Almost. We have one more row. 1, 2, 3, 4, 5, 6, 7, 8. All right, so far, other than the attributes not being correct across the board, you can even force it just to be palette 0 all the way, just to make it simple. So now we've got this water. Oh, okay, so it's just water all the rest of the way, but that's fine. That looks like that's actually probably working based on the other stuff that is we can see where it's updating the tiles in the background. And these are okay. That's okay. That's okay. So that's That's actually not bad. That seems to be working now. You're back. What did you miss? I got the tile loading working, it looks like. From what I can tell. The attribute stuff is totally turned off, so we gotta fix that. I'm kind of dreading going back to that. Let's see here. So if we decrement the screen, what is this? Process branch of equal to process screen mem. Screen mem, load a screen mem, compare to 1F, skip row process. Otherwise, load A23A0. And that's where we start over. Okay, so that all looks good. So now we had a jump to skip attributes that we were doing here. That we need to fix, because that is now ignoring the attributes, which is obviously going to result in it looking wrong. Alright, so let's fix this. So now, compare the metatile flags, JavaScript. Okay, so all of this is all the same. Where it becomes different is we want to load that and then store it in temp and decrement. We only need to do that. Let's see. Load A, store A, branch if not equal. So if it's not 0, branch if equal to set carry, subtract 1, store it into temp, otherwise we're here. Right, so let's see, so we load A with the tile value, we store it into temp, and then, oh, this should be plus. If it's 0, we skip over this part, otherwise we subtract 1 and store it into temp, and then we don't need that anymore, right? I don't think I'm using this. I don't need that anymore. Alright, so then we're shifting. Okay, so now here we're setting the whole. So this is where the attribute stuff gets annoying, because we're setting the whole thing. We're setting the whole thing to the value of the palette used by the metatile, and that's not right. Depending on where we are in the row and all that other stuff. Should we just do... So we're just loading the whole metatile attribute. That's all we're doing here. Do we ever get into a situation debating if we get into a situation like we have with the 32 by 32. With the 32 by 32, we were doing sometimes this whole update, or sometimes an update in one half of one and one half of the other. Now we're doing a 16 by 16 area, so we're always either doing this part of it or that part of it. We're never split across two different bytes, so that makes that easier. It's just a question of, are we in the top half or the lower half? So let's think about how we could figure that out based on Y's position. No. So, I mean, the good news is that basically we're saying, okay, we have a metatile that we've loaded one row of a metatile, for example, at the top of the screen. Now we just need to update 2 bits of the. Now we're just going to update this whole. We're not even going to do just the 2 bits. We're going to do the whole 4 bits for each byte. So half the byte every time. We got to figure out which byte we're in. And then well, you know what? I mean, I'm happy with the progress we've made with loading the tiles. The tiles are loaded properly even if the attributes are wrong. Doesn't seem like the attribute loading is actually breaking the tiles themselves. It's obviously just messing with the colors. I'm just kind of... I'm done with the extent of my mental capacity, I think, at this point. The tiles are being loaded correctly. The attributes are next, and we can pick that up on Thursday of next week. I gotta work on figuring out how I can expedite some of this stuff a little bit faster because, as I've mentioned, I really want to make some more progress in terms of getting the game design and implementation work done, and getting Jordan's art worked into it, and part of that was obviously this changeover to the 16 by 16 metatiles. I gotta fix the enemies and why are they spawning like that, and then make sure also the collision with the background is working. But for now, I think I'm satisfied with the limited progress we've made for the evening. So, as always, thank you for watching. If you have any questions, feel free to message me on Twitter at Clearvis. I'm also on Nintendo Age as Zelius, and write comments on the recording on YouTube, tweet me, whatever. I love that people are interested in what I'm doing and asking questions and learning about NES programming. So it's exciting to have everybody involved. So have a great weekend, and I will again see you on Thursday of next week, where we will, depending on how things go, either continue this or go more into source control, as I had mentioned in a couple of tweets and in the last stream. So have a good night. Thanks for watching. Have a great weekend. Take care.